Enterprises engineering firm, and we've been tasked with designing a wind-powered rope pump. And this is our design team. My name is Cody Belgrave, and I have a keen interest in renewable energy resources, so I'll be handling the wind power system as well as storing the water.
Hi, my name is Jesse Sigulam. I'll be designing an appropriate gearbox mechanism that connects to the rotor shaft, as well as assisting in the conceptualization process.
Hi, good day. I'm Junior D'Souza, and I've excelled in mechanics and machines aspect of engineering, so I'll be dealing with the pulley system in the design of
And my name is Rondell Suraj, and I would be responsible for the primary design, the emergency system, braking system on the pump.
In order to formulate a suitable problem statement, we ask ourselves three questions. What is the problem or need? Who has the problem or need? And why is it important to solve? And for the first question, the problem is that water needs to be pumped from wells to the surface. Who has the problem or need? Farmers without access to running water. And why is it important to solve? To allow for crop growth and irrigation in remote areas. Therefore, the problem statement we formulated is as follows. Farmers need an easy way to pump water from a well in order to irrigate their crops because they live in remote locations where running water isn't readily available.
After we established what the problem was, we broke it down into the major design features that the rope pump would have. These features include the wind power mechanism, the pulley system, the gearbox mechanism, the brake system, the clutch, and the storage tank.
For the wind-powered system, we'll be looking at traditional windmills versus modern turbines. The design of the turbine blades to maximize the power input as well as the axis of rotation, so whether it's going to be a vertical axis or horizontal axis. And the design will include a wind vane so as to allow it to be able to adjust to the wind direction.
In regards to the pulley, certain aspects must be considered. Aspects include the ratio of the system must be determined, the length of the rope attached to the pulley must be determined, the method of transferring of rotational motion must be determined from the wind power mechanism, ensuring enough friction is on the rope to minimize slipping, and the appropriate pistons to select for design.
For the gearbox mechanism, we will be looking at different types of gears to provide speed and torque conversions from a rotating power source to the pulley system. We would also employ a clutch to engage and disengage these gears.
Two brake systems need to be incorporated in the design. A self-locking brake is needed to prevent the downward movement of the pistons in the absence of energy, and also an emergency brake is needed in the design to allow the user to manually stop the pump in the event of self-locking failure. One of the major disadvantages of wind energy is it is not always readily available. A means of storing the energy to be used at a later time is necessary. Compressed air storage, pump hydro storage, and batteries can be used to store the energy. A simpler design, however, would incorporate a self-filling storage tank to be open when required.
So in conclusion, we propose that the wind power be collected via a windmill or a wind turbine, and that power be transmitted through the pulley system to the gearbox. The gearbox then transmits power to the rope, which then forces the water to the storage tank. And from the storage tank, the farmer would be able to access the water to irrigate his crop.